The energy of the radiation, if we measure, it will give you an important characteristic. We'll get back to that. Okay, this is the electromagnetic spectrum. These are gamma rays. This is short wavelength, high frequency, and high energy. And these are the radio waves, long wavelength, small frequency, and small energy. Okay, this is the entire spectrum. Gamma rays, X-rays, then ultraviolet rays. Our visible range is very small. Visible spectrum is what? With GR, right? Violet to red. That is basically, we are talking about 400 nanometers to 750, 800 nanometers roughly. Nanometers of radiation is the visible radiation. After that you get into infrared. It is, here you get microwave. Microwave spectrum you use for cooking as well as radio communications, etc. And then radio waves. Okay, this is the entire spectrum. Each of these regions interact with matter, gives different characteristics. It tells you something about the structure of the molecule, structure of the material. That is what we are interested in. So, now we will talk about molecular energies. That means, see, the entire electromagnetic radiation interacts with matter, affects the energy of the molecule. Affect the energy of the molecule. By measuring that energy of the molecule, we will know the property of the molecule. Okay? So, this is, see, molecular energies are, see, if you take, say for example, what any system, what will be the energies that will be, it will have potential energy and kinetic energy. Okay, Ke plus Pe, that is the total energy. Now let us ignore Pe for the time being. Let us take only kinetic energy. Kinetic energy consists of what? It consists of translation. If you take water molecule in this room, molecules will be moving. That is called translation. Okay, and then it will have rotation. So the water, if you take H2O, right? So OH, right? So it will be rotating around the axis of some bond. That is called rotational energy. And the other one is the vibration. If you take H2O, OH will be stretching. And this energy will be going on continuously. You understand? And then electron will be spinning. Nucleus will be, talk about energy of a system. We are talking about energy of the sum total of all these motions. This is called the energy of molecule. Now, what will happen in the Raman spectroscopy is, Raman spectroscopy will change the vibration of the molecule. So, if we understand the Raman spectroscopy, we will know the vibration. Vibration is related to the bond. That means what will happen, if we study Raman, we will get the characteristics of the bonds. Once we understand the bonds, we will know how many bonds are present in the molecule and we will arrive at the structure of the molecule. We will discuss in detail. Okay, so you all know, right? So this is the molecular energy of a molecule is translational energy plus rotational energy plus vibrational energy plus electron orbital energy, electron spin energy and nuclear spin energy. This is called the sum total of the molecular energy. So now we should take molecular energy levels. If you take s orbital, let us take s orbital from ground state to excited state, that is called the electronic orbital. That means it has high energy. So for electron to transition from the ground state to the excited state, you need a powerful radiation. That is ultraviolet rays. If you use, electron will go from ground state to excited state. And within electronic orbitals, you will have a lot of vibrational levels. So that means what? Here if you have high energy, this energy is less than this. Okay? So if you use visible light, what will happen is, electron can go from here to here with relatively lesser energy compared to this. Lesser energy compared to this. that this is called vibrational transition. Within this vibrational energy, you will have a lot of rotational levels. So that means, and so on. So in the increasing energy, you will have what? Translation, and then nuclear spin, then electron spin, rotation, vibration, and electron orbitals. Is it clear to all of you? So that means translation requires least amount of energy. More than translation, you need nuclear spin. And more than nuclear spin, you need more energy to electron spin transition. And more than that, you need rotational energy transition. And so on. Nuclear spin, can anybody tell me one example of nuclear spin which you have seen in Visakhapatnam? All of you know. MRI, magnetic resonance imaging, right? So people will be like, if I want to have brain scan to study some problem some health problem if I have, that is actually what we are doing there is we are studying the nuclear spin. So here because this requires very small amount of energy, which area of electromagnetic spectrum we will use? Because radio waves require small energy, we use radio waves so that there will be nuclear transition. Say when NMR machine, when the scanners, what they do is they take, say for example, entire body consists of what? Water, right? Mostly water and mostly organic chemicals. Organic chemicals 13 isotope of carbon, or sorry, if I am blocking, you tell me to move. So or carbon 13 or deuterium D, okay, H2, okay. So we will map that and then you get the nuclear spin. Okay. So this is the, anyway, spectroscopic transition. I think I will move little bit faster here. Okay, here this is the spectroscopic process. Like if you take a molecule, give energy from ground state, it will go to excited state, and then it gets back and energy will be released. So initially you are supplying energy so that the electron will move from ground state to upper state. Once it is in the excited state, it cannot remain there. It has to relax. So that relaxation will give you some energy. And this energy we study, and that is the spectroscopic process. Okay, this is the molecular absorption spectrum. Like if a compound absorbs some radiation, the emission will be slightly shifted from the absorption spectrum. That's all you have to understand. See, for example, if they ask you some question later, what is the difference between absorption spectrum and emission spectrum? Always emission spectrum will be shifted to the right. That means for absorption, you need more energy. And some energy will be consumed by the molecule for system changes. Like, or system will lose in the form of heat. Okay? So when it emits, it loses that energy, so it will go to it will have always lesser energy compared to the absorption energy. Am I clear? Do you understand? Absorption energy will be always higher than the emission energy or emission spectrum. So this is the general features of spectroscopy. This is called the intensity. This is called the resolution. Okay. So spectroscopy you can use for quantitative analysis, structure identification, physical parameters, empirical relations, theoretical explanations. We will discuss this bit further. So these are the various reasons and whatever properties they will give. Say for example, gamma rays will give almost elementary particles will be rearranged. Okay, and X-ray will give transition between energy levels. Like electronic energy levels will be changing, and that change you will measure. UV visible will give again information about electronic energy levels, and Raman and infrared will give information about bond energy. That means Raman and infrared, if you study, you will know about the nature of the bonds. Once you know the nature of the bonds, you know the structure of the molecule. Once you know the structure of the molecule, you will know its function. Function means its properties. That means, like, say for example, you think that, like, all problems are solved, etc., etc. How many people think that, like, how many people know about concrete, cement? How many of you know? Cement is discovered some 200 years back, right? Portland cement, this, that, and all. So what you do, you take cement, you mix sand, you pour water, and you keep it for some time, like 21 days or something, pour water. It becomes almost like stone. And that is 200 years back, everybody discovered that. And we all know that, we think that we all understood about cement, right? But you know what is the tallest building right now? Burj Khalifa. Burj Khalifa, when they are building, after 80th floor, normally what they do is, when you are building a skyscraper, you pump the cement. You mix it and you pump it. Nobody can carry it, no. So you will pump it. After 80th floor, what is happening is, when you are pumping it, it is setting in the pipe itself. So all, like, chemists like you, all of you have to sit together and come out with a new process, so that the building can be built. Okay, so the important thing what I'm trying to say is, like, you have to understand the vibrational levels, so that you will come out with the structure of the compound. And if you know the structure of the compound, you know its properties. We don't know fully. Okay, so, and another thing I will tell you, I think you think and you try to come out with, see, scattering. How many of you know about scattering? Principal Garu talked about it, right? Scattering is like sky is blue because of scattering and all. What is scattering intensity? Scattering intensity is I is proportional to 1 by delta to the power of 4. That is the scattering intensity. If that equation is correct, then what is the smallest wavelength? Smallest wavelength is violet, right? Then sky should be violet, right? Why it is blue? I don't know. You think about it and come with an answer. Okay? So that's what. And then microwave and electron spin resonance, nuclear magnetic resonance. Nuclear magnetic resonance, we have spoken. Like, it will give you information about MRI, etc., etc. If you have a peak, then you know that the material is crystalline. If the peak is not there, it is amorphous silicon. Okay, which is, we can tell if somebody gives us same material in crystalline form and amorphous form, we can tell whether it is crystalline or not, or which is crystalline, which is amorphous, by using Raman spectroscopy. And this is called resolution. Resolution is how closely you can separate the wavelengths. How closely you can separate 1 nanometer or 4 nanometer. And how can you define resolution? How many of you studied Bragg's law? Yes. Lambda is 2D sin theta. What is lambda? Lambda is the wavelength. What is D? Distance between the two lights. Okay, and sin theta. Now D is equal to lambda by 2 sin theta. What is theta? Theta is the collection angle. Okay, so here what we are saying, lambda is D by lambda by 2 sin theta. Now I am using, say, 488 blue laser. Then what will be my resolution? Lambda is equal to 2D sin theta. D is equal to lambda by 2 sin theta. Take theta is 90. That means, like, it is 2. Okay? That means that is going to be D is equal to lambda by 2. My light is 488. That means what is my resolution? 244. That is the resolution. That is what you use. No, all of you, I think by the time you are all grown up, like, nobody is using CDs. But if you have you heard of CDs? CD, how CD will function? It will have pits, no? Some laser will be there, small this thing, small opening will be there, and depending on the intensity change, you will know what is the information. It works on the same philosophy. Same philosophy. Lambda is equal to 2d sine theta. D is equal to lambda by 2 sine theta. Now let us assume 2 sine theta is, and and 2 sine theta in microscopy is called numerical aperture. Later, if some of you are biology or chemistry or material science, if you study microscope, synthesize chemicals, and then we can separate them and purify them, and each stage we can establish the nature of the compound, characterization and evaluation. And spectroscopy can be used in chemistry, physics, biology, and we can get chemical structure, molecular dynamics, molecular geometry. That means chemistry is used in all branches of, spectroscopy is used in all branches of science. Okay? In fact, right now what they are doing is they are measuring the blood glucose level using Raman spectroscopy. And they are using angiogram. How many of you are aware of angiogram? Angiogram is they measure the how much blockage is there in the heart valves. So what they do is they take a small fiber, send it through some vein and map the diameter. It will tell you how much it is blocked. Now in that optical fiber you will send a light and you will collect the scattered radiation, and you can also get the Raman mapping. So it will give you information about heart blockages, and it can also distinguish between benign cells and cancerous cells, malignant cells. So it can be used in cancer detection. Like they are trying to develop entire body scan to tell which are the good cells and which are the bad cells. So it can be used in biology, it can be used in material science, it can be used in chemistry, chemical industry, all kinds of industries is used. And it is used in see this is developed by Homeland Security of United States of America after 9/11. How many of you are aware of 9/11? Where the two towers in New York were blasted by terrorists. So after that, your complexion won't change, etc., etc. are there. Now we want to restore some of them. We cannot use whatever we want. Now some Asian paints we put and put, everything will go. Right? Or if you go to our Kalankari, if you go to Lepakshi, you will see all kinds of artwork, using vegetable dyes. You can't use any dye for restoring those kind of art pieces. So you study with Raman spectroscopy, you find out the nature of the dye, use exactly the same dye to restore the exact art. There's some paint was stuck on the car, it met with an accident. So use that, you take the paint and you can establish exactly from where the paint came. Okay? So say for example, how many of you know Rajiv Gandhi during the terrorist attack? So the lead samples came to RSIC IIT Madras. I am a student at that time. So the lead sample we analyze. The moment we analyze lead samples, we know from which factory that lead sample came. See, what they did is they put this explosive belt with lot of some kg of lead pellets. And so you take the lead pellet, you analyze that, then you will know from which factory came. And from that we will also know which country uses, those lead, we source the material from that particular factory. From that we will know which country is behind that. In the same way, all of you, vegetable oils and all will be adulterated, right? So we will take the, all the known companies, they will give their genuine samples. We will know those genuine sample spectrum, and if it is adulterated, you will know how it is adulterated or what it is mixed. Like allotrope of carbon, right? And what is the difference between diamond and graphite? Structure is the difference. Graphite is hexagonal layered structure, whereas diamond is tetrahedral carbon. Like the board structure goes infinitely, right? Tetrahedron will be connected to another tetrahedron and so on and so on. Now it is so strong, the carbon-carbon single bond. It is you require enormous energy to move it. So what you get only symmetric stretching. Detect the symmetric stretching. If you give me two stones, one is diamond, one is a fake. The moment you take the Raman spectroscopy, you will know if 1310 nanometer peak is there, it is actual diamond. Otherwise, somebody is conning us. Okay? Like 110 floors or something. It's almost 1 kilometer tall building. So when they are pumping the cement at 80 floors, after 80 floors, cement is setting. Like cement is becoming solid. So they have to develop a completely new process whereby the cement mixture will be in the semi-liquid phase, so that we can pump it. Tell what is what. So whether it is cocaine, ecstasy, or whatever, all students is simply this. All of us are intelligent. Even animals are intelligent, right? See, for example, how many times you saw cats and dogs when the bus is going, they will run away from the road. They don't die, right? They know that there is some danger coming, they run. So we are all intelligent. The difference between people who learn, people who don't, or the people who work hard. All of us are we all have the same intelligence, not much different. The thing is, you have to work hard. If you don't understand, you have to read till you understand. You should not give up. The moment you give up, there are many opportunities for us to give up. Like, if you ask me, the moment I get up, I don't want to work. I want to sleep, I want to see movies. Working is difficult. Learning is difficult. It's not easy. But you have, I will go, you will buy, you always want fried rice or vegetable manchurian, right? You don't want whatever curry, this, that. But still your mother will do, she will, how many times you said, thank you mother? When the food is good, how many times you appreciated your mother? They are sacrificing so much so that you will learn, you will educate yourself, and then you will live far more comfortably than themselves. Right? Every parent wants their children to be better than them. So that is why you have to work hard. You have to work hard for yourself, as well as a lot of people are making sacrifices to you. And learning is a joy. You should, once you start enjoying learning, you will, nothing will stop you. You will go very far. See, there is one of the greatest musicians. He's called Tumarad Sangameswara Sastri. Actually, Ramakrishna's surname is, he is from Sangam village in Srikakulam district. When he played in Shantiniketan, Rabindranath Tagore gave him golden Saraswati Vigraha. He is called Abhinav Saraswati. So, how many of you know about Carnatic music? None of you, right? Anyway, there are 72 ragas from which all tunes are constructed. There are 7 talas. Like tala means the beat. So, Sangameswara, he will not stand like this. Right? When bowler is bowling, he won't stand like this. Sachin Tendulkar is the greatest batsman. Even then, he has to stand like this. That means there is a... My pleasure.
B. Vendela. Mata Radiga. Vinita. Rahashi. Kavya. Harshini. Revati. Vendela.
కంగ్రాచులేషన్స్. చదువుకో.
సార్ నాకు ఒక డౌట్ సార్,
ఆ.
ఉన్న క్లాస్ స్కై ఎందుకు బ్లూ కలర్ లో ఉంటున్నాయి?
ఇది అయిపోయింది చెప్తా. ఓకే. కంగ్రాచులేషన్స్, ఆల్ ది బెస్ట్. Congratulations.
I request all the chemistry faculty to join this institution.
Thank you.
Congratulations.
K. Kavya. Harshit. Revati.
Congratulations.